Example 122. In a 2007 study of different popular diets, 77 people used a modified version of the Atkins diet for 1 year. Their mean weight change was negative 10.34 pounds. Assume that the population standard deviation for all such weight changes is known to be 15.51 pounds. Use a significance level of 0.05 to test the claim that the mean weight change is equal to 0. Does the diet seem to be effective? Does the mean weight change seem substantial enough to justify the diet? And what assumptions are necessary for the test we just conducted to be valid? Okay, so let's go ahead and look at this problem and recognize first that the problem asks us to test the claim. When you see that phrase, test the claim, it's a hypothesis test of some sort. So it says test the claim that the mean, right? So it's a hypothesis test about the mean, and then they're going to tell us the claim, right? So test the claim. And our first step is going to be to identify the original claim, right? So in this problem, test the claim that the mean weight change is equal to 0. So let's do that up here. Our claim is that the mean is simply equal to 0. And that would mean here that if there was no weight change, if the mean weight change was 0, it would mean essentially that the Atkins diet does not work because there would be no change in weight. Okay, so that's the claim, and now let's look at HO, HA. Well, HO and HA will be based on what the claim is. If the claim has an equal sign, it becomes HO because that's one of the symbols that HO uses in equal sign. So I'm going to go ahead and say that the null hypothesis here is that the mean is equal to 0. All right, now for the alternative hypothesis, we're going to say that it has to be the opposite of whatever the null hypothesis is here. So we're going to say that it's not equal to 0, right? That expresses the opposite idea of what the null is saying. Okay, so we have our claim. We have our two competing hypotheses, right? So we've done steps 1 and 2. Now we do step 3, which is to record the data from the problem. In these problems, we're going to usually have a sample size. We'll have a sample mean. We'll have some kind of a standard deviation. In this case, it says it's the population value, so we're going to use that. And then finally, we will have an alpha level. So let's look at the end for the problem. It says 77 people used the diet, right? So 77 people were in the study and involved in this particular phase of it. The sample mean, it says their mean weight change was negative 10.34 pounds. So negative 10.34 pounds. And then the standard deviation, it says assume the population standard deviation is known to be 15.51. So 15.51 pounds. And then we have the significance level, and they claim, or they say that that significance level is 0.05. So this is our data for the problem. We're going to take that data now, and we're going to use it in our next step of the process, which is part 4. We're going to calculate the test stat. So to calculate the test stat, we're going to use the formula. Because the sample size is large here, because it's 77, I'm going to write z equals to x bar minus the mean sub 0, fraction bar, sigma over the square root of n. Okay, so let's fill in what we know here. The sample mean is negative 10.34. Then we have this quantity here. It's minus mu sub 0. Minus mu sub 0 is the value that we take from the null hypothesis, h sub 0, and that's going to give you 0 in this particular case, right? The number in the null is 0. When we're done with that, we're going to draw a a fraction bar. We're going to do sigma, which was 15.51. And then we're going to divide by the square root of n, the square root in this case of 77. Okay, at this point, the next thing we're going to do is to do the calculation of it, right? So let's go ahead and enter this all in our calculator at once. Now the top is just going to be negative 10.34. Since we're just subtracting by 0, I'm not going to put that part. Then divide by, parenthesis, 15.51 divided by the square root of 77. So I'll close up my square root, close up my bottom denominator's parenthesis, hit enter, and I get a very extreme test stat. It's approximately negative 5.85, which would indicate a pretty extreme result. And this means that there is a large difference between 0 and negative 10.34 pounds, and this would indicate that there's something wrong with the null hypothesis. It's not close to what we saw in the sample data, which indicates the null is probably wrong. To confirm that, we're going to do step 5, which is going to be to come up with our rejection region. To do the rejection region, remember, you draw a bell curve, right? And you look at the HA in the problem to determine whether we have a one-tailed test or a two-tailed test. Now when I look at HA, I see not equal to, and it tells me then I should draw basically two tails on my drawing. Now, those two tails will contain alpha together, right? All together, 5% will be divided into these two tails. So what we need to do is we need to find the critical value here, and that critical value in this case is going to be a Z alpha divided by 2 value. It's alpha divided by 2 because remember that alpha here is going to be split into two tails. So just remember when it's not equal to for HA, you divide the alpha in 2, and that's what goes in here. So we're going to say that it's half of 5%, or 0 to 5 in this tail, and likewise there'll be half of that in this tail, 0.025. All right, so from there, remember that this is your rejection region, right? And this is your do not reject area, right? So we need to figure out where these two critical values are. Remember the one on the left will be negative. Okay, so let's go to our table. Let's look up 0.025 in one tail, and that will help figure out what numbers go here and here. Okay, so we're looking up 0.025 in one tail, and we're going to go straight to the bottom. So let's see what that gives us in this middle column here. All right, so it looks like the value is 1.96. 1.96. Okay, so we found our answer to be 1.96, and of course it'll be negative 1.96 on the left, and that's because the center here is 0. All right, now that you have the critical values, we look to see where this number, our test stat, lands on this number line down here underneath the bell curve. And I think it's pretty clear that that test stat is well into the rejection region on the left-hand side. So I'm going to say, hey, this number is definitely going to land somewhere over here. Remember, if you're over there, your conclusion is going to be to reject the null hypothesis. So if you're in this shaded region, we reject the null. And so on this side as well. So that brings us to step 6, which is our initial conclusion. And what we're going to say here in step 6 is that we should reject the null hypothesis, and therefore, as a partner to that, we're going to support the alternative hypothesis. So keep in mind that these come as a pair, right? You can't get one without the other. If you decide that you reject the null because the test stat lands in the rejection region, it means you also support the alternative, because if the null should be rejected, that means it's basically wrong, and that means the other one must be right. But for the final wording of your answer, which is our last step, step 7, you have to make sure that you address the claim itself, not, HO or HA. So what I mean by that is look at your claim and say to yourself, okay, I'm either going to use the phrasing that I reject it or I support it. That's what I have to figure out next. So when I look at the claim, I ask myself, is the claim HO or HA for this problem? Well, in this particular problem, the claim and HO are the same, so it means I will use this wording in the end. I'm going to go ahead and say that I reject the claim. So I reject the claim, and remember what the claim was saying. It was saying the mean weight change was 0, meaning that you didn't lose any weight on the Atkins diet. But we reject that because it seems that this weight is significant enough to say that the diet does cause weight change. So our answer here in words is going to be, it looks like my marker ran out a little bit there, so I'm going to use it in red. Our answer in word is going to be very simple. We're going to say there is sufficient evidence to reject the claim. And you can fill in the rest of it afterwards, right? Reject the claim, of course, of what? What's the claim here? The claim is that the mean weight change is equal to 0. Or in other words, there's sufficient evidence to reject the claim that the Atkins diet does not work. All right, so let's now quickly answer these last questions. It says, does the diet seem to be effective? Well, statistically speaking, it is effective, meaning that the weight change that occurred here was due to the diet. That's what we can say with statistics. But however, we cannot necessarily answer this with statistics. It says, does the mean weight change seem substantial enough to justify the diet? Well, it's a year of deprivation, right? They were on this diet for 1 full year, a year without, tasty carbohydrates like cakes and chips and cookies and potato chips and things like that, bread, all the things that people love, even, in many cases, cereals. So there are a lot of things that you have to give up to be on this diet. So I would guess that some people would argue that no, that weight change isn't good enough over the course of the year to do this particular diet. Maybe there's another diet that's less difficult, or maybe the exercise regime would be better, etc. So the bottom line is that statistics can't answer that kind of a question. It can answer statistical significance. It can't answer practical significance. So practical significance means, hey, in everyday language, when we think of the word significant, we think, is it meaningful or important? That's really up to you to decide whether this is enough weight to lose over a year to make it justified to get on the diet, right? Of course, some people lost more and some people lost less, but the idea is on average, that's what you can expect to lose if you were on this diet for 1 full year. And then last, it says, what are the assumptions necessary for the test to be valid? Well, those assumptions are pretty simple. We used a bell curve down here, so we somehow assumed normality. We were able to make that assumption because the problem deals with x bar, and x bar, according to the central limit theorem, is normally distributed whenever the sample size is over 30. So this sample size of 77 allowed us to use a z distribution, or a bell curve. And then, of course, as usual, we would want to have a random sample of people involved in the study because we want to make sure that the study isn't somehow biased in some way. So getting a good random sample of the population would help to ensure that.